Hello friends, welcome back, and today we are going to solve the 23rd problem of 30-day lead coding challenge. So today's problem is bitwise AND of numbers. So basically we are given with a range of numbers m, n, both are inclusive, and we have to return the bitwise AND of all the numbers in this range inclusive. So for example, they have given two example 5 to 7, and then the answer is 4, and shortly I will discuss how this answer 4. And similarly here for 0 1 interval we have answer 0. So here we are finding and of all the elements from index from number 5 to 7. So let's see, I have prepared some explanation for this problem. So for the first example 5 to 7, here are the numbers, binary representation of 5, then 6 and 7. So if we go on finding the AND operation, the result of AND operation among all these numbers, we will eventually find it to be 100, which is 4. And let's say we expand our interval to from 5 7 to 5 8, that is introducing one more element 8. So what happens here, 8 is actually 2 raised to 3, so we get exactly this 1 and triple 0. So right now we had a result 100, which has only 3 digits in its binary representation, and here in this we have 3 digits, but all of them are zeros and the fourth digit is 1. So whenever we AND this by this we get 0. And further, if we increase this if we expand this interval to any number, then we will always get 0, because once we get 0 and we try to AND it with any other number, we will always get 0. So if I expand the interval to be 5 comma x, where x is greater than equal to 8, then it is always going to be 0. So this is happening just because of the transformation, that is the number of digits in the binary representation of the number is changing from 3 to 4 or to any higher number. So whenever such a transformation happens, be sure that the answer will always be 0, irrespective of the length of this range. So we will explore this further. I have written down some binary representations of numbers from 1 to 16. So if you just try to look around and see these patterns here, so whenever you will find that whenever you have uh, m and n having equal number of digits in their binary representation, then only there is some possibility of getting any positive answer. Otherwise, if m has lower number of digits and n has higher number of digits in its binary representation, then we will get 0, that's for sure. So, and here you will realize that the answer is totally dependent upon m and n, so we don't need any middle element between m and n. So we will see how this solution works. So the solution is like we have to actually find out um, in m, if let's say this is our m and this is our n, then we have to actually find out how many digits from left to right are exactly same in m and n. So here 101 is same in both m and n. From left to right we have to see, and the rest will be 0 in the answer. So our answer will be 1010. Likewise, if we choose this as our m and this as our n, then we see that only the first number is same, that is 1, rest are different. So our answer will be 1000. So this will be our answer. So basically this is happening so because um, if m has the same element as n, then that will always be equal from the left side, but we are not sure about the right side, and that will always be leading to 0 if we and all of the elements in between. So our solution is we have to find out the number of digits in m and n in their binary representation, and then if they are same, then we will try to find out how many of the digits are same, exactly the same in both m and n. And if they are not same, that means the number of digits are not same, then we will just return 0. So let's try to solve the problem. So first of all, we will have to keep account of number of digits in m. So for that I am assigning cm equal to 0. Similarly in n, that is also equal to 0. Then we have to store um, these given values m and n. So I'm taking f and z for that. Now we will find out the number of digits in m and n. So I'm sorry, while m is greater than 0, then m divided by equal to 2 and cm plus plus. So this will give us the count of number of digits in m. Then we have while n greater than 0, n divided by equal to 2 and cn plus plus. So this will give us the count of number of digits in n. Now we have to check if these two are equal or not. If they are equal, we will find out how many digits are exactly same from left side, and if they are not equal, we will return simply 0. So first let's find out if cm is equal to cn, then we have to do something. So and if else, we just return 0. So now we will find out our answer. Let's say we have int, we are taking a variable for counting the power of 2. So let's say if a is equal to 0, and we have to store our answer. So answer is equal to 0. Now while we have stored our values of m and n in f and g, so we will use that here. If so, while f is greater than 0, then what we have to check here is if f percent 2 is equal to g percent 2, then we have to um, update our answer plus equal to power of 2 comma a, and we will multiply it with whatever is the value of f percent 2. So we are just doing, if it is 0 then we will add 0, if it is 1 we will add the power of 2 raised to a. So, and if uh, they are not same, if the digits are not same, then we have to update answer is equal to 0. That means till now from the right side we have encountered some different digits, zeros and ones. So now if divide by is equal to 2, and similarly we have to update g divide by equal to 2 and a plus plus. So now we have got our answer, so we have to return our answer. So let's see if this solution works. Fine. So run code. Yes, let's submit it. Yes, so we have got it accepted. So that's how it works. Thank you for watching and hope you enjoyed and learned from the session. Thank you.